Hello and good day to you, my dear senior high school student. This is Mrs. Rowena Olofernes, your general mathematics teacher. Welcome to the new and exciting lesson in general mathematics. But before that, let me ask you this. How are you? Kumusta? Today, are you feeling excited for our new lesson? Are you feeling loved? Or are you happy? Or maybe bored, sleepy, or even sad? Well, if you're bored, sleepy, or sad, then don't forget this is a pre-recorded lesson. So I'll give you time to rest or take time to rest and be back after a few minutes or hours if needed. And be right back once you are all ready. Do you understand? As much as possible, I want you to be comfortable as we nourish your minds and enhance your mathematical skills. Since you continued viewing this video presentation, then that means you are all set. You are ready for our new lesson. So let's begin. In this video presentation, we will tackle about Quarter 2, Module 7, Lesson number 2, about logical operators. Be ready with your General Mathematics Module 7 and your paper and pen. You will be needing that as you follow the discussion. Remember, you can always pause and play this video whenever necessary. So we are all set? Let's start the lesson. What you need to know. At the end of the lesson, you are expected to recognize different types of logical operators, execute different types of operations on propositions, and demonstrate perseverance and open-mindedness in performing the task. What's in? It's review time. Let's review what you have learned in the previous lesson. Let's recall the symbols for connectives together with their respective types of compound propositions. This time, students, I want you to open your internet browser. If you're using your mobile phone, don't worry, you can still open any browser that is available. You can open your Google Chrome, Safari, Firefox or Mozilla Firefox, or even Opera or Opera Mini. We will be using Kahoot to review the lesson. We will be using Kahoot to review your previous lesson. This will be an asynchronous activity. So that means you can access this within the week. And make sure to answer this before you proceed to the next part of the video presentation. Have you opened your browser already? Good. I want you to type in kahoot.it as what you see on the screen. That is spelled as Kahoot.it. Kahoot.it. And once you opened it, it will ask you for your game pin. Type in this game pin, the one you see on the screen. I repeat, type in the game pin and press enter. You can pause this part of the video to see the game pin and play our review game. Okay, students, I hope you're in. You may now start the game. Enjoy the review and see you in a little while. Done with the review? How was it? If you got all the answers correctly, excellent work, students! If not, if you forgot some or most of the symbols or even the compound propositions, don't worry, feel free to revisit your previous lesson. That's lesson 1 of module 7. Let's continue. What's new? I want you to understand this statement. The teacher promised her students, if you pass the final examination and submit all the requirements, then you may join the graduation. I repeat, this is the teacher's promise. If you pass the final examination and submit all the requirements, then you may join the graduation. The student passes only the final exam, but the teacher allows her to join the graduation. What do you think about this? I have here some guide questions for you to follow. Has the teacher broken her original promise? What do you think? And when can you say that the promise was broken? And explain it in mathematical sense. And how can you determine the truthfulness of the statement? These are questions for you to ponder. I want you to express your thoughts about this. So let's communicate virtually and asynchronously through this application, the one that you see below. That's with Padlet. So I want you to open again your internet browser, whether you're using your personal computer, laptop, or mobile phones, any of those, you can type in the URL of this one. Type in the URL that you see on the screen and it will lead you to our Padlet. If it's your first time, don't worry, I'll guide you all throughout. Or if you're using your mobile phone, you can simply scan on this QR code and it will lead you directly to our Padlet. Go ahead. I'll give you time. When you open the link, you will see something like this. Welcome to our Padlet. Here you will see the original question, the teacher's promise to her students. You will also see here the guide questions provided. So you have their 3 questions. And for you to write down your answers, you need to type in right here. And once you're done typing in your answer to our guide questions, then you may click on the word post to post your answers. And we will communicate there virtually or asynchronously in our Padlet. And I'm super excited to read all your answers for our guide questions. Don't forget to visit our Padlet. As your guide, I'll be showing again the slide for our guide questions. Take your time. Okay, students, let's proceed to the main highlights of this lesson. What is it? The main topic for this lesson is all about logical operators. To understand this further, let's understand first everything about truth table. In creating our truth table, we will be making use of different propositions, the one that you've learned in the previous lesson. If X and Y are frequently used letter in algebra, letters P, Q, and are often used to represent propositions in logic. While a variable in algebra can make any value, a variable, the P, Q, and R in logic has only true or false for its value. Like this. So your proposition P has values true or false only. Same goes with Q and R. True or false are the numerical constant of logic. A proposition is a declarative sentence or statement that is either true or false. True is denoted by capital T, while false is denoted by capital F. For a proposition, it can only be true or false, but never both. It's neither true nor false. Let's look at some examples. Identify if this given statement is a proposition or not. I am answering my module honestly. What do you think? Is it a proposition or not? This is an example of a proposition because this statement is a declarative sentence. At the same time, it can be true that you are answering your module honestly, and hopefully you are doing it with all honesty. At the same time, that statement could also be false, right? If that person or student is not answering with honesty. How about this? Do you want to have face-to-face classes? Is that a proposition or not? The answer is, since a question is not a declarative sentence, it fails to be a proposition. It's neither true nor false. How about this one? This sentence is false. What do you think? Is it a proposition or not? This is a tricky one. What happens if you assume that this statement is true? So if you're telling us that this sentence is true, then it's false? Well, it can neither be true nor false. This is actually an example of a paradox and is not a proposition because it is neither true nor false. Given the proposition P, earlier that was, I am answering my module honestly. Let's construct its truth table. We will copy first the label of the proposition P and we are going to write it at the upper row, right there. Since there are two possibilities for our proposition that can either be true, that's T, or false, that's capital F. So your truth table would look like this for a single proposition. How about if we add one more proposition? Let's have proposition P and proposition Q. That means we are going to add one more column for our proposition Q, like this. Since we already have true and true for both P and Q, at the same time false and false for both P and Q, we still have rooms for other combinations. So it could be our P is true while our Q is false, or vice versa. Our P is false and our Q is true. So a truth table involving n propositions has 2 raised to the power of n rows.
So if you are going to construct your truth table, you need to determine the number of propositions. So if there are 2 propositions, you will change here the n to number 2. For example, here at the top, we will use that formula 2 to the power of n to identify the number of rows below our label. So that's 2 raised to the power of n. We will change n by 2, so it will be like this. 2 raised to the power of 2, which will give us 4. So we now have 1, 2, 3, and 4 rows. So this truth table has 4 rows below our label for P and Q. Alright, and let's make use of this knowledge to fully understand logical operators. Let's start examining the first symbol. That's the symbol for negation. When we have proposition P, our truth table looks like this. Using the symbol for negation, meaning we will negate our proposition P, we will add a new column for that, and it would look like this. You read it as not P. Negation symbol with proposition P, you read it as not P. So this is P and this is not P. So if your proposition P is true, then the negation or not P is its opposite. That will be false. And if your proposition P is false, then not P or its negation will be the opposite. That will be true. Do you understand? Nice. Let's have an example. Your proposition P is 2 is an odd number. What do you think is not P? Or what do you think is its negation? I'll give you time to think. Okay, let's check. The answer here is the negation of 2 is an odd number will be 2 is not an odd number. I repeat, 2 is not an odd number. When you have not P, that means you will also see not in the statement for our negation. Let's determine the truthfulness of this example. For our proposition P, it's false, since 2 is obviously not an odd number. So that means our negation or not P is true. Do you follow? Okay, great. Let's have another example. Let's say your proposition P is ML or Mobile Legends is an e-sport. What do you think is not P? Or what do you think is its negation? Go ahead and pause the video. Well, the answer for that is ML or Mobile Legends is not an e-sport. Let's check its truthfulness. The proposition P is true because Mobile Legends is considered as an e-sport. So our negation is a false statement. Good job, students. That's for negation. 1 down. Let's proceed to the second part. That will be conjunction. Let's look into the truth table of 2 propositions P and Q. It looks like this. Remember, we have this in the earlier slides. In conjunction, we are making use of this symbol for the connective. That will be the symbol for and. So you read this one as P and Q. I repeat, that's P and Q. The connective and implies the idea of both. For the conjunction P and Q to be true, both P and Q must be true. Otherwise, the conjunction is false. So looking at the next row, P and Q are both true. That means P and Q is true. Second row is true for P and Q is false. Since one is false, that means P and Q is false, right? Because both must be true for them to be true. Next one. How about false for P and C or true for Q? Same. That will be false. And the last one is both are false or expected that our answer here is false. Remember this? It would only be true for a conjunction if both P and Q are true. Otherwise, you will have the statement to be false. Let's have an example. Let's say your proposition P is, today is Monday. And your proposition Q is, today is raining. What do you think is the conjunction P and Q? You may pause this video. Okay, so P and Q here is, today is Monday and it is raining. P here is this one, today is Monday. Q there is this, it is raining. And your connective, which is and. So the answer here is, today is Monday and it is raining. How about making use of negation, the one that you've learned earlier? Let's say you have this. How do you read that? That will be P and, remember this? Not Q. So again, that will be P and not Q. So how do we get the answer of P and not Q? The answer is, today is Monday and it is not raining. Since the proposition Q is already have its negation, that's not Q, therefore you will add not for this part. It is not raining, just to emphasize on the not. And that's for conjunction. Let's proceed to the next one. That would be disjunction, having that symbol. Let's make use of the truth table for two propositions, P and Q. Same with earlier. Like this. And we are going to add one more column for our disjunction. It would look like this. And you read the connective as or. So you read this one as P or Q. One more time, you read it as P or Q. The connective or implies that if P is true or Q is true, or both P and Q are true, then the statement is true. So let's try to look at its truth table. So if your P is true and your Q is true, both here are true, the expected answer here for our disjunction is, what do you think? That will be true. Good job. Since both are true, the expected answer for our disjunction is true. How about for the second one? With P true and our Q as false, what do you think is the answer right here? That would be true, because if P is Q, then the statement is already true. How about the third one? If P is false and Q is true, the answer is still true, because either P or Q would be true, automatically the sentence or the statement will be true, or even both for P and Q. The last one here is you have false for both P and Q. So the answer is false. Remember that? It will be true if one, like P or Q, or both are true. Otherwise, it will be false. Let's look at some examples. If your proposition P is, Neil is a senior high school student. With a proposition Q, Dina is a chemistry teacher. What do you think is the disjunction? P or Q? Again, what do you think is P or Q? You may pause this video and play once you're ready. Okay, so let's reveal the answer. P or Q is Neil is a senior high school student, or Dina is a chemistry teacher. That would be your P, and this is your Q, and that will be for your connective or, the connective for your disjunction. That's read as or. How about making use of our previous knowledge for negation, like this? How do you read this one? This would be not P or Q. I repeat, you read it as not P or Q. So what do you think is the answer? This time, you negate the proposition P and retained the proposition Q. The answer will be Neil is not a senior high school student. That's the negation of proposition P. Or Dina is a chemistry teacher. So that would be our answer for not P or Q. I hope you're following. So that's for disjunction. So far, so good. Let's move on to the next one. This time, let's talk about conditional statements. Making use of the same table for our propositions P and Q, we have this. Adding one more column for our conditional statement, we have this. That would be the connective for conditional statements. You read it as implies. Our proposition P is also called the hypothesis, and our proposition Q is our conclusion. And you read this conditional statement as P implies Q. Another way of reading that is if P, then Q. One more time. If you see this symbol, that means it's a conditional statement. Written in words, you will have it as P implies Q, meaning the proposition P implies proposition Q. Or another way is you will have if P, then Q. So if proposition P, then proposition Q. Let's examine its truth table. If both the hypothesis and the conclusion are true, then the answer is true. If one is true, let's say the hypothesis right here, and your conclusion is false, then it is a false statement. The conditional statement is a false statement. If your hypothesis is false and your conclusion is true, then your conditional statement is true. And finally, if both the hypothesis and conclusion are false statements, then your conditional statement is true. Okay, so this is now the truth table for your conditional statements. Remember this part. It would only be false. Again, the conditional statement would only be false if your hypothesis or your proposition P is true and your conclusion or proposition Q is false. Let's look at an example. Here, we'll start with your conditional statement. Your conditional statement here is, if J.O. is in grade 11, then he is a senior high school student. Our P or proposition P here is, J.O. is in grade 11. Remember, that's if P, then Q. So if P, so that means this is our P. How about our Q? He is a senior high school student. So that would be our proposition Q. And this one, since it's the connective for conditional statement, then that will be for if then or implies. So here, in our example, we are using if P, then Q. Let's check the truthfulness of this statement. If our proposition P is true and our proposition Q is true, then therefore, this conditional statement right here is true. How about if our proposition P is false, but the proposition Q is true? This is an example of a true statement based on the truth table for conditional statements. How about if P is true and our Q is false? Then that means the conditional statement now is false. And that's for conditional statements. Let's proceed to the last one. That will be biconditional statements. Making use of the truth table for propositions P and Q, let's add one more column. The symbol for the connective for our biconditional is like this. Double-headed arrow, which we read as P if and only if Q. I repeat, when you see this symbol, you'll read it as P if and only if Q, where our P and Q are known as the components of the biconditional. Let's check the truth table for the biconditional. If both are true, then that's true. If true for P and false for Q, that will be false. If your P is false and your Q is true, that would be false. And if both P and Q are false, then the biconditional is true. Observe, if both are true or false, then the biconditional is a true statement. Otherwise, if one is false, either P or Q, then that means your biconditional statement is false. Let's have an example. Let's look at this biconditional. Jayo is in grade 11 if and only if he is a senior high school student. This is similar to our example for conditional. So our proposition P here is Jayo is in grade 11, and our proposition Q is he is a senior high school student. Let's check the truthfulness of this statement. If P is true and Q is true, then the biconditional statement is true. Okay, how about if P is true and Q is false? So our biconditional statement here, Jayo is in grade 11 if and only if he is a senior high school student, will now be false. So that's for biconditional. So those were the 5 logical operators. If you want to go back to a particular logical operator and master that topic, then don't worry, you can always replay that portion of this video. You can always go back and repeat the video presentation. So those were the 5 logical operators. Let's go back to our main problem. Remember this? The one that you've answered in our Padlet. Let's try to answer the 3 questions or the 3 guide questions after understanding the logical operators. Let's answer the first question. Has the teacher broken her original promise? Now let's recall. The promise of the teacher is, if you pass the final examination and submit all the requirements, then you may join the graduation. But the student only passes the final exam, but the teacher allows her to join the graduation. So what do you think after understanding logical operators? Has the teacher broken her original promise? Now let's scrutinize. Let's look into the original promise. You see there your clue. You have there if, then. Can you recall what kind of statement this one is? If you will see if, then, that means, yes, it's for conditional statements, right? So we will be making use of conditional statement truth table to understand if this one is a true statement or false, or if the teacher has broken her original promise. But try to observe our first proposition. That's proposition P, making use of the conditional statement. It's being underlined and pointed. If you pass the final examination and submit all the requirements. Notice that you have the connective and. So this is a bit tricky because it's a combination of different logical operators. So when you say that there's the presence of the connective and, we need to consider conjunction. Our proposition P will be pass the final examination. And our proposition Q is submit all the requirements. So looking into our conjunction truth table, pass the final examination for P and Q is submit all the requirements. Since the student passes only the final examination, which means our P here is true, and he or she was not able to submit all the requirements, making our Q as false, then that means the conjunction is false. So that means our proposition P earlier for the conditional statement would also be false. So let's remember that. False. Going back to conditional statement. So earlier, we have identified that this is our P and this would be our Q for the conditional statement, right? And we also have identified using conjunction truth table that the value of our P right here is false. One down. Let's identify the Q. Then you may join the graduation. The teacher allows the student to join the graduation. So which means our Q is true. So basing on our conditional statement truth table, that would be at this row. False for P and true for Q. What is the value of our conditional statement? That's true, meaning this statement is true. To answer our question, has the teacher broken her original promise? Well, the answer for that would be no. Do you follow? Meaning, the teacher has kept her promise. So the answer again is no. To answer the next question, when can you say that the promise was broken? Considering the original promise of the teacher following a conditional statement, so basing on its truth table, it would only be false if your proposition P is true and your proposition Q is false. That's the only time that the conditional statement will be false, which means that the promise will be broken. Let's answer the final question. How can you determine the truthfulness of the statement? You need to identify first what kind of statement is given. Either it's a conjunction, disjunction, conditional, biconditional, or negation. And examine its truth table. We've answered the 3 questions already. I hope I made it clear. If you still have further questions about this, then do not hesitate to message me in our group chat. Then I'll be very happy to answer all of your questions. Okay, let's move on. What's more? Now, students, it's your turn. Complete the truth table for the given statements by filling in the required columns. So you have here 1, 2, 3, 4, and 5. Or you may scan the QR code and it will directly lead you to the Google form for this question. Or you may also type in the link provided on the screen, which is this one. If you opted for printed modules, don't worry. Then you can also submit your papers or modules, your answers, during our retrieval of outputs. Assessment. You may take a screenshot of this or pause the video to answer the question. We have 3 scenarios. Scenario A, B, and C. Read the situation carefully and determine whether the condition P implies Q is true in each of the scenarios given. That's scenario A, B, or C. So your answer here is true or false. I'll give you time. You may pause the video. Now this time, let's talk about the application of this topic into other fields. This topic about logical operators or in logic in general is the basic foundation in computer science. It follows this binary language, which is 1 and 0, which means 1 in logic that's true and 0 is false. The popular examples of its application is how virtual assistants like Siri is used in gadgets, mobile phones, tablets, or even in laptops. We also have Alexa by Amazon, which is also a virtual assistant. There are a lot of applications of logic in the topic of artificial intelligence technology. All right, still under application. Let's extend beyond what we can do. So here, we will try to explore coding as one of the basics of computer science. Are you excited to learn how to code? I hope that's a yes. And I know you're very familiar with Minecraft. So this time, you are going to open your URL and type in the link that you see on the screen. We are going to start coding, meaning we are going to play a game, which is Minecraft. So again, copy the link, type in the link that you see in the screen into your URL. To guide you, it would look like this. So after typing in code.org/Minecraft, it would lead you to this. Once you're there, don't forget to sign in using any of your accounts. It could be your Gmail accounts. Well, if you don't have any accounts, then you have there the option to create your account. Once done, you will see something like this. In this game, you are going to stretch your mind and apply what you have learned by playing Minecraft. So after visiting the site, you'll have it this one. You will see this. You will tell the character that you have chosen on what to do by coding the instructions. Here, it needs a lot of logic to pass the course. It's a very brief course, and once you're done enjoying and playing the game, a proof of completion will be given to you. It means that you were successful, like this. It's the hour of code. You'll receive a certificate with your name on it as a proof that you have completed your mission. Again, this is a real-time application of what you have learned for our topic about logical operators. You're playing the game, you're enjoying, at the same time, you are critically thinking. Let me leave you with this quote to ponder. This is by Anonymous. The truth is still the truth, even if no one believes it. A lie is still a lie, even if everyone believes it. Do you agree or disagree? Let me hear your thoughts in our group chat or messenger.
And that concludes our lesson number 2 of Module 7. So good job for today, and congratulations for always doing your best. And see you in the next lesson.